Hi everyone, welcome back to Prietology. I know with this coronavirus pandemic, these are difficult times. So since a lot of schools are out and not a lot of people are learning a lot of things, I was thinking that I could bring my knowledge of science because I love science. It's a beautiful thing to study. So I was thinking I could bring my knowledge of science to you guys and, well, teach you guys about science. So basically what I'm going to do, this, as you saw in the title, this is Season 1, Episode 1. So basically today, each day I'm going to do lessons based on like different topics. So today you saw is the basics of chemistry. So that's what today's episode will be about. So I don't think there's any other aspects. So let's get started. Okay, so everyone, this is where we'll be doing our lessons. So as you see, today's lesson is the basics of chemistry. Okay, so what I'm going to try to do, I'm going to try to make this as simple as possible to help you as viewers understand, because some of these things that I know are a little too complex, so I'm going to try to make it as simple and understanding for you. So we won't go into stuff like super hard stuff. I'm going to try to keep it like understandable level for you guys. So, so today we see our key terms. We have solid, liquid, gas, plasma, melting/boiling point, Brownian motion, element, compound, mixture, and the glorious periodic table. So let's start with solid. So that fell. Okay, so a solid is okay, let me write over here. So see, you guys see me in the camera. So solid is there's three main points of a solid. So a solid is the lowest energy state. So it has the lowest energy out of all the states of matter. I'm pretty sure you guys probably know some examples of solids, like you. You are a solid. Everything on this table is a solid except for my water bottle here. Okay, and another thing. So another critical aspect of solids, it has a fixed volume. What I mean by fixed volume is it has volume. Like every solid, like if you're in math, you have to measure like how much space something takes up, right? It's a volume. So all solids have fixed volume. Okay, another critical aspect of solids is slow atoms. So atoms inside a solid are very slow. So you can see my model atom here. You can see off the camera. Can you see it? Yeah. Yep. There's my atom thingy. So this thing is going to be representing. So the atoms inside every solid that we know are very slow. They're not incredibly fast, unlike gases, which have very fast electrons. These atoms move very slowly. Okay, so let me just scroll to the next point. Okay, so another speaking of volume as well, solids also resist a change in volume unless you, well, liquefy them. Also, atoms inside solids have a crystal structure, so, and hence diamonds have a crystal structure. Another solid, plastic has a crystal structure inside, but I won't get too much into that. Okay, now let's go to the next key term and look at that. Also, I forgot to mention, at the end of every class, I'm going to try to do something that you guys can do at home. I'm going to do like an experiment of the day, so I'm going to try to make it interactive for you guys. So the next term that we're going to be talking about is liquids. Liquids have, like solid, they have three main aspects. Liquids have they kind of have a fixed shape and volume. So liquids basically, they fill up any container that you put them in, and you can change their volume by putting them in any container. Okay, so another aspect, like the what's it called? The solids. They have medium state. So they're like the state in between solids and gases. So they're like that They're like that kind of solid kind of gas, so they're like that bar line. Okay, another point about liquids, like I said, is they have medium speed atoms. So let's take our little model atom again. So this little model atom, it doesn't move incredibly fast, but it's, like I said, it's like liquid is basically like the middle line of all the states of matter. They have like all the middle line characteristics. So an atom would move like slowly like that, and you're able to fix its shape. And an example of a liquid is water, probably the most important liquid of them all. Okay, so another thing about liquid, if you want a little more complex stuff, when there's attraction between liquid, that is called surface tension. If you haven't heard it, you can see the term up here. Where is it? Okay, so you could, if you heat up a liquid, you'll decrease the pressure of the liquid as well. And then you'll decrease the pressure. Okay, so also this is another like complex thing that you could know. So if there's some liquids that can dissolve solids like acid, some acids can burn right through like concrete. Those liquids are called solvents. Okay, so now the next term, we covered solid and liquid. The next term is gas. A very, very interesting state of matter. Okay, so the characteristics we have identified in solid and liquid, this has no fixed volume. It'll never have fixed volume, and it will never have it in the history of the universe. It's just ready to run free whenever it wants to. And then, okay, next characteristic, fast. Just put very in parentheses. Atoms. Okay. So the atoms, let's go to our model atom again. The atoms move incredibly fast. The hotter it gets, so heat has to play a special role in this. So when you heat up an atom, it gets faster and faster and faster and faster and faster and faster, and that's what makes these states change. And that's when we get into melting point later. Okay. It is also the highest energy. This is the state of matter with the highest energy. So some examples of gases are, if you look around you, you're surrounded by a gas. Air is a gas. Okay, and some other little like non-essential things that you don't need to know is that it's usually invisible. Gases are usually invisible. Well, if you have chlorine gas, it's really, really toxic. It has like a pale green color. Iodine gas. Iodine is an element where it has a very low boiling point, around 102 Fahrenheit. It's around 102 Fahrenheit. So when you burn it, oh, I just dropped my marker. So when you burn it, it turns into like a vibrant pink gas. That's pretty cool, but you still shouldn't breathe it. So this is not the same for gas. This is the same for anyone. So when gas is exerting a force, that can also be felt as pressure. Hence the air pressure. All the air pressure from the atmosphere just pressing on you, and that can be felt as well, air pressure. Okay, so the next state of matter, there's actually one above gas, but it's not common. Well, if you set something on fire every day, then yeah, it's common. The state of matter is called plasma. Plasma is basically just like a step above gas, so it's basically ionized. So ionized, you'll learn that in next week's episode when we discover the parts of atoms and like the subatomic particles. So if you're wondering about an example of ionized gas, fire. Fire is plasma. Fire is basically just ionized gas. That's basically what it is. Okay, so the next terms, we covered all the states of matter, and there's one below solid, but that's a lab-made matter. I won't get into that. That's bogus numbers, which is too complex for you guys. So we're going to be talking about, I'm going to do this in separate parts. So first, melting points. So the melting point is when, let me see my notes, when a solid, so I'm going to put a diagram here. So a solid That's going to represent our solids. So actually, let me just do a key to begin with. So solids, I'm going to represent them with a square. So this is a solid. I'm going to make a drop. That's my drop. It's not the best drop. That's going to represent liquid. And then gases, I'll represent them by like a sphere. Yes. So that's going to represent our stuff. So melting point is when a solid goes into a liquid. So basically the melting point is a measure of how easily forces, like the heat forces, how easily forces inside solids are broken. So when you heat up a solid, the atoms vibrate. So like I said earlier, the atoms, when you heat them up, they vibrate more and more and more. So they get really, really hot, and then they're able to melt the solid. Okay, so our next point that we will talk about is the boiling point. This is kind of like the melting point. So it's like a transition between different states of matter. So the boiling point in all elements and materials is when a liquid turns into a gas. Okay, so it's basically, like I said, it's basically a measure of how the forces inside liquid are destroyed. So the process is the intermolecular forces ripping apart the atoms and basically turning into a gas. But I won't go into like forces until we get into physics, which is in about 4 episodes. So basically, like I said, your little atom is heated up, and then it basically, like the forces of it just moving around, so that just rip the liquid's molecules apart and then basically turning them into a gas because there's so much heat. There's some other points that I won't get into. So like when a gas turns into a liquid, you might have heard this term condensation. That is when a gas turns into a liquid. I'm just going to represent that by a triangle house. When a liquid turns into a solid, that is a freezing point. Some other ones are when this is one that not many know. This is when a solid doesn't stop at liquid; it goes directly to a gas. That is called sublimation. An example of that is if you've ever seen dry ice, it's a solid, right? It's frozen carbon dioxide. And you see it like expelling gas all over the place. That is sublimation. That is a solid going directly to a gas. Okay, so the next term that we're going to discuss, it's a little more complex, but I'm going to try to simplify it to you. It is called, here, Brownian motion. Okay. So basically what this is it's basically a description on how particles move around in liquids and gases, not solids, only liquids and gases. So I'm going to try to explain this. So as you see here, this is actually coming out from a real story with the guy who invented this. I forgot what his name was. I'm just going to call him Mr. Brown for now. So what he did, so when he was examining pollen under a microscope, he just saw it moving all of a sudden, like it just started fidgeting, and then Albert Einstein, and then later, like probably like 150 years later, Albert Einstein's like, it is moving because of Brownian motion. All the molecules inside, like I've been saying, the molecules, as you see my little atom guy here, they're moving around. They're basically like bumping into the sides and making the liquid or gas move. So that's how the liquids and gases can move in real life. Also, that has to do with inertia and forces and all that stuff, but we'll get to that later. Okay, so the next term is elements. There are, I think we're going to discuss 3 things you should know about elements. 1, they are the building blocks of the universe. They're the building blocks of the universe. Every single solid, liquid, and gas that you see, except for the non-artificial ones, which we'll get to later. Every single solid, liquid, and gas you see has one of these elements. And it's not just one element out there. There are 118 elements known to man, which only 92 of them occur naturally. Okay. So as elements get heavier and heavier and heavier, they go in like this order. So first we have the first element is, just move it over here if we need to move the camera. So the first element is hydrogen, represented with H. So hydrogen has, let me see my notes really quick, has one proton, so one proton, and protons are always represented with a P, and the plus sign next to it, and one electron. And electrons have a negative charge, which we'll get to next class. So they have a negative charge, so they have an E, so they have a minus right next to them. So helium is number one. Helium is the lightest thing in the universe, and it's the most abundant thing in the universe as well. Helium is He, that's the chemical symbol. So helium has 2 protons and 2 neutrons. Neutrons have no charge at all. They're neutral. And the electrons vary from element to element. So as you see here, we can basically like predict how elements will change. So like the next element is lithium. If you've heard of lithium-ion batteries, this is element number 3. It has 3 protons and I think some number of electrons, but we'll get to that later. Okay, so if you see on the periodic table, I'm just going to do hydrogen for example. So the characteristics of an element can vary. So hydrogen, if you always look at a square on the periodic table, which we'll get to later, the number up here in the corner is the atomic number. The atomic number is, like I said, hydrogen is the first one proton. The atomic number is the number of protons in the nucleus. And then there's some words down here. Usually the words down here is the name of the element. So hydrogen, that's number 1. Usually they have like the ionic charge, but I won't get into that. I don't know the ionic charge of some elements. And then up here in the corner, which I think is yes, right here is the, I'm just gonna put some, I think it's 1.00139. That is the atomic mass. The atomic mass is the nucleus. So if you know, the nucleus of an atom is the protons and the neutrons, not the electrons. The electrons, so if you see here, the electrons pretend some electrons. So the electrons orbit the atoms. So the atomic mass, it's a very different scale. It's not kilograms or pounds. It's a very different scale. I think it's called mole. It's called mole, like a mole, M-O-L-E. It's not the animal. Let me see here. So mole, it's a chemical. It's a way to measure atoms. So I'm not going to get into that. So don't worry about that. So that's basically what the atomic mass is. Okay, so now term number 8 is compounds. You can't really see that. Let me erase this. Okay, I think you'll be able to see it now, so. I don't know why you're still not able to see this. Okay, so compound. So compounds, look at my notes here. Compounds are, let's not down my water. So compounds, they are a combination of different elements. They are a combination of different elements. So compounds, they can be destroyed and they can be made by chemical reactions. So let me give a good example. They like to form. There's 2 types of compounds. There's ionic compounds and covalent compounds. An example of an ionic compound is salt. Salt is an ionic compound. I think we're gonna get to like ions on the next video. So next class. An example of a covalent compound is water again. So compounds. So like I said, Salt, if you know, is sodium chloride. That's a combination of two different elements. And water is hydrogen and oxygen. So compounds, like I said, are a combination of different elements. Okay, so the next term is mixture. Mixture. And if you think they're like compounds, you are wrong. Compounds and mixtures are very different things. Mixtures are two substances mixed together. So a good example for a mixture is they can be separated by physical means. So and they cannot be made by chemical reactions. So an example of a mixture, I have this little bag of. So this is like I saw it in a book. This book called Chemistry by Basher, and I'll have a link down in the description if you are thinking about buying it. So a mixture is like a good this book said a bag of marbles. It's a really good example of a mixture because they're not fused together like you see. Let me just pull out two marbles. So I have a red and an orange marble. So you can't. So like compounds would fuse them together, so they would be red and orange. That's like light red. This is a dark red. And mixtures just put them together. They don't fuse them together. They don't fuse them. They just side by side. And then what I mean by physical means is like, for example, this is your mixture. You can take out, like, for example, you can take out a yellow. You can take out a red. That fell. You can take out a red one. You can take out multiple. So basically, that's what a mixture is. Okay, so the last term that we were talking about today, and it's my favorite term, is the periodic table. One of my favorite topics to talk about in science. So just get my notes here. So I say, well, most scientists outside the world say it is one of the most important discoveries of all time. I'm trying to put a clock here. Okay, there's all time. So basically, the periodic table, it's basically a chart, as you can see here in my periodic table here. It's basically a chart to organize all the elements, all 119, into like different categories. So as you see, the vertical lines here, they are called groups, and the vertical ones, are called groups. The horizontal lines, like one here, one here, one here. These two top here, that is considered one line. Those are called periods. So these are categorized into like different categories depending on their reactivity, use. Basically, they're categorized on that. And like I said, they move on from left to right based on their atomic number, which we learned is the number of protons in the nucleus of the atom. So basically, I'm gonna like tell you what their uses are and what the categories. So the first category, I'm just gonna move this here. Let me see if I can spell it here. Is alkali metals. These metals are very notorious for blowing up. So basically these metals, lithium, sodium, potassium, rubidium, cesium, and francium, they all react with water and air. So usually they usually just start fizzing and then they catch on fire and then they blow up. That's basically how the alkali metals work. And an alkali metal example that I'm pretty sure you have in your home is a lithium-ion battery here. You can see here this lithium-ion battery. It contains lithium, which here is element number 3. And it's actually it's the softest metal of them all. So that's basically what's in the lithium-ion battery. Okay. So let's move on to the next category, which is alkaline. Now alkaline alkaline earth metals. These metals, they kind of react like the alkali metals, except except instead of like blowing up, they release they ignite and they release colors like magnesium. Magnesium here. If you heard of magnesium, it's infamous for making, when you burn it, it's infamous for sending off bright white flames everywhere, and it's very bright. You should not look at it. What's another one that you probably guys know here? Calcium. Calcium is also very flammable as well. It's a metal, if you did not know that. It's used for building parts of the body, like the bones and the teeth. So basically, yeah, that's basically what they're for. I thought I had an example here. Okay, so let me just take my notes. Okay, so let's move on to the next category. Okay, so category number 3, okay, is the Great Transition metals. These metals, this little group here, these metals are used in industry a lot. So as you see here, I have some examples of the alkali metals. As you can see here, I have of the transition metals. I have here the lock. If you can see on the camera, I have a lock here. I just have scrap metal. These are probably used for using the transition metals. Some common ones that you guys probably know is titanium, iron, copper, zinc, silver, gold. Gold is on there. Some of these elements are really toxic, like mercury. I'm pretty sure you guys know mercury. And cadmium. I don't know if you guys know what cadmium is. It distorts the muscle in the brain and it just kills you over time. It's another one you guys probably know. Tungsten. I don't know if you guys know that's used in incandescent light bulbs because it is the toughest element around. It doesn't melt until 3,000 Celsius, which is about 8,000 Fahrenheit about. So yeah, let's move on to the next element category. So category number 4 is Category number 4 is the poor metals. The poor metals, they include this little triangle right here, this little wedge here. They are the poor metals. Some poor metals that you know, lead. What's another one? Tin. Tin and lead. Tin is used in tin can. Lead. Gallium. Gallium has a melting point of around 85 degrees Fahrenheit, its melting point, its freezing point is 85 degrees Fahrenheit, but if it's hotter and you bring it down to 85, it'll melt. So basically, these guys have a better electroconductivity, and they're kind of like transition metals along with the lanthanide, which I'll talk about later. So these guys, basically what they do is they have a lower boiling point than other metals, like this one, gallium, I said it's 85 degrees Fahrenheit. So basically they have a lower boiling point and higher electrical conductivity. Okay, let's move on to the next one. The next one is the non-metals. The non-metals include elements like nitrogen, oxygen, phosphorus, sulfur, basically, and also selenium. Those are non-metals. Well, I'm pretty sure you know what non-metals are. They don't have metal. Also, hydrogen fits into that category as well. They are good for electrical insulators, which we will get to electricity and magnetism later in this classes. So basically, electrical insulators, they stop electricity, and we will get into conductors and insulators later. We will get into conductors and insulators level. There are two types of nonmetals. There's polyatomic and diatomic, which I won't get into because that's more complex stuff. So the one, as you see, we've covered the elements here in this triangle and here, but we never covered the elements that go right in between right there. You see this little line? and covers elements that go there. Those are called the, that's not spelled metal. They are metals, fun fact. Metalloids. They're metalloids. So I also call them the semiconductors. Semiconductors. So basically what these guys are good for is, oh, I forgot to show you an example. So this is an example of a poor metal, aluminum. Aluminum is a poor metal, so that's one example. So the semiconductors are really, really good for using in electronics. Here's my Arduino board. You can look at my Arduino video. So this Arduino board usually uses elements like silicon and germanium. Those are very highly used electronic pieces, and they're widely used in and those are widely listed in the metalloids. Okay, so the next category is one of my favorite categories of them all. It's this next category is the halogen. Oh gosh, I can't spell. Let's do that again. What's this one? Halogens. These are the halogens. This line right here, all of those elements are the halogens. These guys like to react with anything they can find. Anything. Fluorine is considered the most reactive element on the periodic table. It can react with plastic, other elements react with every single other. It can even break. It can react with glass, which is basically very dull. So basically, these guys are very reactive and sometimes very toxic and poisonous. Like this one, and this one. Well, basically, all of them are toxic and poisonous. So don't eat them. Okay. The next category is another good category to talk about as well. It is the noble gases. Also an example of halogens. You probably have a halogen in your room. Toothpaste uses fluorine or fluoride. So it uses fluorine, which is one of the elements in the halogens, which is very, very, very reactive. So, noble gases, they are all gases except for this one. This is an element that I'll get to later. These elements don't react with anything. They will never react with anything you find. And when you run electricity, so if you have some in like a tube, when you run electricity through them, they make bright colors. So an example here would be my plasma lamp, if you just turn the camera over here. My plasma lamp has noble gases inside, and that's how you can see the colors through the lamp. That's how, like I said, when you run electricity from noble gases, they excite and they make cool colors. Okay, so the next category is category number 9. We just finished talking about the noble gases. So next is the lanthanides. These guys, they're not super special. They're basically transition metals, but they're located at the bottom of the table. They have weird names, and they're used in a lot of like electronic parts, like TVs and phones and like MRIs. Most of these elements are used in MRIs. So they're kind of like the metalloids or / semiconductors. So one they're really good here. So one of these parts in here, I think that little metal part with the disc around it is made of one of these elements. I think terbium. Terbium is made out of, and also another element that you may have heard of that's on here is neodymium. Neodymium magnets, they make some of the strongest magnets in the world. Okay, so the category below it, which I do not have an example for it, you'll see why. The next element category, is the actinides. These elements at the bottom, this bottom row, all these elements, every single one of these elements is radioactive. No matter what, and up to uranium, which I'm pretty sure you guys know what that is. So this one, They're the last naturally occurring elements in the world. All the other ones from beyond, so element 92 and above, element 93 and above, those are all artificial elements. You can't find them in real life. Some people say that they don't have any uses. They have I think there's one element with one use. It's called americium, which is named after America. It is used in smoke detectors. It's like a tiny little cube of it, but it's very shielded, so you don't get radiation poisoning. So yeah, it's basically used in smoke detectors. Okay, last and not least category is, I'm not going to cover too much on this because it's very short. So the unknown. The unknown kind of sounds like, ooh, it's very weird. These elements, like the elements above 103 and above, they have no use. They have very short lives, and they're not a solid, liquid, or gas. The people who have made them, like Berkeley University of California, they only made like an atom of it, and they last only for like 20 seconds. So they don't have any use besides just scientific discoveries. Okay, so I think we finished covering the key terms for today. So now we will get into the experiment of the day. So let's get started. Okay, so this is the experiment of the day. So each class, at the end of the day, I'm going to show you guys an experiment that you guys can do at home. So today's experiment of the day is from this book called The Big Book of Science Experiments. I put a link down in the description, so if you want to purchase it, it's right there. Okay, so we are going to go to physical science. Let me just find it really quick. Page 95. Here we go. So I'm pretty sure you guys have done this at home, so let's get started. So what you need vinegar, salt, a timer, a teaspoon, a bowl, and some tarnished pennies. By tarnished, I mean they kind of look like dirty and stuff. Like if you see this penny here, it's a little dirty compared to this penny right here, which is nice and shiny. So this has to do with chemical reactions. So the experiment of the day that we'll probably do is probably going to be related to what we learned today in the class. So macro, let me just get some. Oh boy, where did it go? Here we go. Okay, so first direction that to do. So you just move all this here. Fill the bowl 1/4 full with vinegar. So I'm just gonna pour this vinegar here. That's about 1/4, right?
Yeah.
Good. So the next, add 1 teaspoon or 5 milliliters of salt. So I'm just gonna take this over here. Add a teaspoon of that. That's about a teaspoon, right? It's about a teaspoon.
It's about a teaspoon. It's not a teaspoon.
What is it about? That looks like a teaspoon.
That's less than a teaspoon, but go for it.
Okay, so that goes in there. That goes in the mix. So
Did you get
add the
something to
pennies.
mix it?
Yeah. Let me just mix it up at the end of this. You can clean this part later. I'm just gonna put it on.
You didn't mix the salt in. It's on the bottom.
I'm gonna mix this a little more.
It's still.
Okay, let's just not mix it for now. So let's leave it like that.
It seriously smells.
Okay, so step 3, add the pennies. So you take some tarnished pennies, like I said, dirty pennies, and you add them in.
Oh my nose.
And now we set a timer for 5 minutes, and we wait for 5 minutes. Okay, so 5 minutes are up, so let me just reset this. And the pennies look different now. So let me just wipe it with the... I'm going to close this so I don't spill any vinegar. So let me just clean this up. And there you go. Shiny penny again. Just pull out this one. This one looks a little dirtier. But I think once I wash the grime off of it, it'll look shiny again. So hopefully it'll look shiny again.
Just keep scrubbing.
It's a little shiny here. I think I needed to put it in a little longer than the 5 minutes it said. This one looks shiny again. And so does this one. Okay, so you might be wondering what is happening. So what is happening? A chemical reaction is taking place. So when the penny gets dirty, it has like a green color, brown, black, green color to it. That's because it's reacting with the oxygen in the atmosphere to get all dirty and stuff. So when you put it in a liquid, like we discussed today in our class, so when you put it inside a liquid, when you combine vinegar, which is an acid, which we'll learn about later, when you have an acid, and then when you have the vinegar acid, and then you add it with salt, you actually create an acid called hydrochloric acid, which is the same acid in your stomach. Fun fact. So basically what happens, the acid takes away the oxide layer because it's all dirty from the oxide layer. So the acid takes it away and you're left with basically shiny pennies. So basically that's how our classes are gonna work now. So we are gonna have this every other day. So next week we're gonna do a challenge that you'll have to see. So subscribe and find out. Then the week after that we will be discussing season 1, episode 2. Basically we're gonna be talking about the parts of atoms. So basically like atoms, protons, neutrons, electrons, ions. I've mentioned ion a lot today. So next class you'll learn more about ions. So if you want me to, I'm also starting to run out of ideas for videos. So if you want me to use your ideas for videos, comment down below your ideas.
Or you could ask me.
Or you could ask my sister, who's right behind me filming. So thank you for watching. Like, share, and subscribe. Get this video to the front page, and I'll see you later.